You've probably seen these kinds of issues before. And if you're watching this, there's a good chance you're dealing with them now. You've read what others have shared, and you're curious to see how this could apply to your machines, your workflow. Requesting a demo is a simple first step. It lets you see how we approach these challenges using our hardware controller and no-code software builder platform. Define required features based on your machine specifications. You can select any combination of functional modules from our hardware catalog. Everything is tailored to support your machine's architecture. No unnecessary features, no extra costs. Choose the plan that aligns with your typical needs or go with a fully custom option if your machines require something more specific. You'll also choose the business model that fits your company's way of working. Whether you prefer to own everything up front or keep things flexible with a subscription, both options are available. Once your setup is complete, you can request a quote. We'll get back to you with a detailed offer within 24 hours. If you're looking for a more efficient way to build and deliver your machines, this might be worth exploring. In just a few clicks, users can create fully custom widgets and dashboards, personalizing functionality and layouts to fit any application. First, a new widget type is created. Users can select icons, adjust button colors, and configure the appearance based on their application needs. Next, a custom dashboard type is built by adding different elements, including readouts, graphs, and the custom-created widgets. Each element can be positioned and configured directly through the visual editor. Multiple dashboards types can be created for different use cases. For example, a product dashboard for machine operation and a test dashboard for execution and monitoring of the tests. Created dashboard types are used in the Machine Builder products, adjusting functionality for the end-user application. Machine Builder can define default data channels for the readouts and graphs. For each button inside a widget, functionality is defined by setting up rules. Rules are created using triggers, conditions, and actions, allowing users to define how the machine should respond to different events. The dashboards and widgets built here are later used in the machine's end-user applications, enabling a fully customized user experience without the need for traditional software development. Machine builders can use software to create and configure a product type, a reusable template that represents a series or family of machines. For example, a universal testing machine series ranging from 10 kilonewtons to 500 kilonewtons. The process starts with entering general information about the machine type, such as controller model, unit system, supported specimen types, dashboards types. Next, hardware channels are configured. Each channel defines how the controller connects to sensors, actuators, or other I/O devices, mapping direction and type for each port. Sensors are added and linked to their channels. You can define the sensor type, filter settings, and other relevant information. Variables are created to allow data transfer between software parts, like measurements or test procedures. Measurements are then defined, either directly from sensors or derived using formulas. For example, a stress measurement can be created by combining force and cross-sectional area. Actuators are added and assigned to channels. These are then used to create axes, defining physical movement and machine structure. Control logic is configured next, linking axes and measurements through algorithms like PID. You define control type, the source of feedback, and additional algorithms, enabling precise real-time behavior. Calculations can be included in the product type as well, used later in automated test workflows. You also define which dashboards will be available to the end user, selecting from existing layout templates. Finally, rules are configured to define machine behavior in specific scenarios. Each rule includes triggers, optional conditions, and actions. For example, stopping a test when an emergency input is activated. Once complete, the product type acts as a blueprint for building consistent, validated machines, faster and with fewer errors. Managing customers and building tailored machine applications starts here. You begin by creating a new customer profile, entering company details and contact information. Once added, the customer is saved in your database and ready for configuration. Next, you create users under that customer. Assign roles like operator or administrator, and add as many users as needed per role. If your product requires different access levels, You can define new user types and set custom permissions, offering full flexibility. With the organization and user roles already set up, we can now create a product for the customer. Start by selecting the appropriate product type, corresponding to the machine series this specific unit belongs to. All predefined configurations from the product type are automatically applied to the new product. Next, it's time to connect the controller, plug in the actuator cable, load and strain channels, LVDT sensor, Ethernet cable, and power up the controller. Connections are complete. Now assign a controller in the software by selecting its serial number, binding it directly to that machine. Next, define the sensors that will be used. Select the manufacturer, input serial numbers, and prepare them for calibration. The software supports both linear and piecewise calibration methods. In this case, the force sensor is calibrated using the piecewise method, allowing up to 50 data points for precise mapping. The digital encoder is calibrated using a linear profile. Other adjustments can be done for the product if different from the product type configuration. Once setup is complete, the product is ready to be built as a standalone Windows application. Track the build status in real time and download the installer package once it's ready. The result is a fully custom application, complete with your logo, dashboards, widgets, and machine-specific configurations, ready to deliver to your customer. Let's now install the end-user application. The installation process of the application is quick and straightforward. Once completed, a desktop shortcut is created with your company's custom logo, giving the end-user application a fully branded look and feel. Now that the software is installed, we can create the first test. You can add and define standard names, the specimen type for which the test is created, set the unit system, and choose the execution and analysis dashboards. The main section of the test is the test configuration, where we define test stages. Each stage includes 3 parts: pre-stage, main stage, and post-stage. In the main stage, we define the axis movement by selecting the control and specifying waveform parameters. For each stage, we can also define which calculations to perform, such as modulus of elasticity, yield offset, or statistical calculations. Additionally, we configure which channels to log and the data logging parameters. It's also possible to define rules for each stage or for the entire test. For example, we can set a rule to detect specimen break and define what actions to take when it occurs. Next, we create the specimens to be tested, either individually or as a batch. Then comes the report configuration, where we define report details and choose which test calculations and specimen parameters to include. The test is now ready to be executed. The software supports both simple, single-stage procedures and complex multi-stage tests with pre- and post-test actions, looping functionality, and more. We're ready to run the first test with the built and installed software. Select the test you want to run, attach the specimen to the machine, then choose the specimen from the batch and start the test. This example uses a simple tensile test with the rule setup to automatically stop once the specimen breaks. As soon as the test finishes, the software prompts you to load and select the next specimen. After completing all required tests, you can generate reports, either for the entire batch or for individual specimens. The list clearly shows each specimen's status, whether it's tested, broken, or still pending. Creating a report takes just one click. It includes all test details, graph, specimen parameters, and calculated results. The software supports both static and advanced fatigue tests. During the running test, you can fine-tune control or waveform parameters live during execution to achieve optimal performance.